What's up, guys? Mr. C here with a lesson 11.1. So we're done with that conic section chapter. We might be done in this chapter. I don't know. We're gonna we weren't technically finished with chapter 10. Since we're kind of crunched on time, I'm gonna be jumping a little bit towards the end of the year. So we're jumping around to lesson 11.1 today. And chapter 11 is all about probability. So we're going to be talking about permutations and combinations today. I'm pretty positive you guys have all seen this. So it'll probably be a refresher for most of you. Let's go ahead and jump right into it. We're going to talk about most important thing of probability is this thing called the fundamental counting principle. And so here's the idea behind this thing. Let's say we have a cafeteria menu, all right? You go to a cafeteria, and you're able to pick one of each item for your meal. So you could pick one sandwich, one side, and one dessert, and that is a meal. So if you were trying to decide how many different meals there are, meal combinations there are, okay, here's how you would do that. You would see, okay, can buy a hamburger, cheeseburger, veggie burger, or PB&J. So I have 1, 2, 3, 4 options. Sides, I have 1, 2, 3 options. Desserts, I have 1, 2, 3, 4 options. So if we're trying to find the total number of combinations of meals you could have, this is the fundamental counting principle. We have 4 options times 3 options times 4 options. Okay, and this is the total number of outcomes of meals. So 4 times 3 will give us a 12, times another 4. There should be 48 total meals, total unique combinations of meals. All right, so that's what we use the fundamental counting principle for. All right, so that's that. Let's talk about factorials. That's that little exclamation point thing you might see in your calculator. Okay, now what a factorial means, if I had like 7 factorial, okay, what this means is to take 7 times 6 times 5 times 4 times 3 times 2 times 1, okay? So that is a factorial. And by definition, it's probably good to mention that 0 factorial, by definition, is just 1, okay? I don't know that we'll run into that in this section, but just so you know, 0 factorial is one kind of a special case there. So when do we use factorials? Let's say you wanted to rearrange 5 books. Okay, so you have 5 books, and you want to arrange these on a shelf. Okay, well, how many different ways can you arrange them, or how many different orders are there? So we're putting them on the shelf. Placing the first book on the shelf, we have 5 choices. Okay, but when we place the second book, we've already used 1 book, so now we only have 4 choices. 3 choices, 2 choices, and then for the last one, we only have 1 choice. So this is really the fundamental counting principle in play when we're talking about the number of choices that we're multiplying, and it comes out to be basically a factorial. So whenever we're arranging something or trying to find arrangements, that would be able to be considered a factorial. So 5 times 4 is 20, times 3 is 60, times 2, this should be 120. So if you had 5 books you were trying to arrange on a shelf, there were 120 different combinations for those. Okay. Now a permutation is basically the same idea, but let's say I'm not arranging all 5 books. I'm only arranging a number of them. So let's say I have 5 books to choose from, but I'm only picking 3 to put on the shelf. Okay, let's say I have 5 books, but I'm only picking 3. Well, if we think about it this way again, that's pretty easy. There's 5 of them, so I do 5. There's 4 of them, so I do 4. Now there's 3 of them, I do 3. But since I'm only choosing 3 books, I end there. So 5 times 4 is 20 times 3. That would give me a 60. Okay, so that's basically the biggest difference between a permutation and a just regular old factorial. Now, there's a formula for this because if you start using larger numbers than 5 and 3, that's going to be kind of annoying to have to write all this out, use your calculator to do that. So there's actually a formula that kind of does that for us. I don't know if you guys can hear that. It's pretty loud where I am. Sounds like Wes is probably going to be taking a bath. I'm in the basement, and I think the water's running. So I apologize if this is going to be really loud. I'll move the laptop a little bit closer. So formula for permutations looks like this. Okay, if you didn't want to write it out like this every time. We would say the number, how many we're picking. So n is the total. Let me do it this way. N is the total. R is the number to pick. Okay. So this formula is going to be n factorial over n minus r factorial. Okay, n factorial over n minus r factorial. And if we were using the formula in this case, that would look like, okay, if we did 5p3, that is 5 factorial over 5 minus 3 factorial. So that is 5 factorial divided by 2 factorial. Okay? And that would be the formula. And again, that's 60. There's also a button in your calculator if you guys have the TIs. If you guys, I think, hit math probability, there should be a permutation button and a combination button where you could just put this right in your calculator to get 60. Or if you want, you can use the formula here and just do 5 factorial divided by 2 factorial. That should give it to you as well. Okay, so that's a permutation. Then there's one last thing we're going to talk about, which is a combination. Okay, and a combination is like a permutation, except order doesn't matter. Okay, orders doesn't matter. So let's think about something like this. Say you have 10 runners. Okay, and top, we'll do 7, will qualify for the next round. Okay, you have 10 runners and the top 7 will qualify for the next round. Okay, this would be an example of a combination and not a permutation. Why? Because if I'm picking 7 out of this group of 10, it doesn't really matter what order I pick them in. Okay? And I'll say that again. It doesn't really matter what order I pick them in, right? Because the top 7 will qualify. So if I have 10 people here, 1, 2, 3, 4, this is getting annoying, 5, 6, 7, 8, 9, 10. That's much easier. Let's just use numbers. So 4, 3, 2, 1. Okay, I have 10 people. Let's say the first 7 qualify. Who cares what order I pick them in? Just the first 7 are going on. This is different than if you were doing like a championship race where you're awarding like a first, second, and third place. Those are actually different positions. Top 7 going on and qualifying, who cares? Grab the top 7, doesn't matter what order they finished. So this would be an example of combination. The difference in the formula is this. It is n factorial over n minus r factorial. So it's still that, and we tack on an extra r factorial in the denominator. Okay? So that's my formula. So if I was trying to find this 10C7, It's 10 factorial over 10 minus 7, which is 3 factorial, times 7 factorial. And basically what this part does is it kind of divides by all of the ones we accidentally counted twice. So it's kind of like if I took 1, 2, 3, 4, 5, 6, and 7, that's one outcome. Well, let's say I picked 1 first, then 3, then I picked 2, 4, 5, 6, and 7. Okay, I kind of accidentally counted the same group twice. So what this does is that divides by all the ones I accidentally would have counted by twice. So that is that. Let's just go ahead. If that doesn't make sense, just know the formula. I know I'm kind of going on and on. Just know the formula and you should be good. So let's do that. 10 factorial over, actually, it's probably easier. Let's just use the calculator because I know this has it. Statistics. No, it's not in statistics. It's not in there. I was pretty sure it's here. There it is. Okay. Combination. So we're going to do 10, choose 7. All right, and there are 120 different ways in which to qualify 7 people on a race of 10. So 120. Okay, would be my answer for that. All right. I hope I didn't try to over-explain that one. I felt like I did. But if you have questions, let me know. Hopefully that makes sense because I'm pretty sure you guys have all seen this before. So maybe even some of you just jump straight to the homework, which wouldn't surprise me. But all right, that's all I have for right now. I will talk to you guys later. Peace.